All right, why don't we use that as the point to kick off here since we've gotten rid of the bees. Welcome everybody to the October 2nd, 2025 meeting of the Technical Advisory Council of the Confidential Computing Consortium. Today we have adjusted our schedule. Mike? Okay. Today we've adjusted our schedule, so we're going to work to try to get everything done in an hour. So we're going to try to be efficient with our time. If this is your first time joining, we are an open and collaborative community. We want your input in this meeting, just as we want constructive input into our projects and working groups. Several of our companies are in the same market, so we abide by the antitrust policy. You can read about that at linuxfoundation.org. And this is what we have on the agenda for today. We've got a quick topic on getting some committee volunteers to look at research fund proposals for the new research fund that we're bringing out. The second thing that we have is to introduce the budget for the budget topics for 2026. And that's probably a longer discussion than we're going to finalize today, but I at least want to get the ball moving on especially what are the big ticket items that we want to fund for 2026. And then we want to allocate the back half of the meeting for a tech talk by TikTok on an anonymous attestation project. And I see Ming Shen is on, so looking forward to hearing more about that in the second half of the meeting. Any other topics that people were expecting to have on the agenda for today? All right, so let's do a quick roll. We don't have a vote, but I just want to check in. Thanks, Paul and Catherine, for joining. Do we have? Nope. Always a bad time for Huawei. Scott. I think I saw Scott on.
Yeah. Hi.
Yes. Hey, Scott. Thanks for joining. Henry or Kevin? Nope. Alec, thanks for joining. Fritz, thanks for joining. Saw Yash on Slack. Okay, no Yash at the moment. Mingshen, thanks for joining. And we are Bobless today. All right. So if this is your first time, you're welcome to introduce yourself to the committee. And Catherine, I see your hand is raised. Go ahead, Catherine.
Yeah, I have a small announcement to make. As of yesterday, I was no longer with the Confidential Computing organization. I moved to a different organization within Google. So we are trying to find a replacement for me. So I'm just kind of pre-announce here. So I might not join next meeting. Hopefully we'll find a qualified candidate to join, to represent Google and join this committee.
Well, Catherine, there can be no replacement for you.
Thank you. That was so sweet. I want to say that it was great working with you all, and it was a great committee, and was a pleasure. Thank you so much.
Well, thanks for all your contributions. It was great having your help getting the kernel SIG operational in particular. Okay, well, that also throws a kink into my plans for having you co-chair next week's meeting and having Google's updates there. I wonder if we can still maybe coordinate an update from the kernel SIG during that meeting. I know I've not been able to attend recently, so I don't know if somebody from Google who has been helping facilitate those meetings would be available.
I'll look into that.
Okay, thank you.
No problem.
All right, now this is supposed to be the part of the meeting where new people come, not people leave. So no more of that. Adam, go ahead.
Hi, new guy here, Adam Powers. I run privacy for Amazon devices and services. So that's everything from Alexa to Fire TV, Kindle, satellites, robots, cars, photos. all that sort of stuff. So really interested in the technology and interested in seeing where the committee is going.
Fantastic. Great to have you joining us, Adam.
Thanks.
And Dan, if you don't mind, this is my first time joining. Thanks for moving the meeting because I always have a standing conflict on the first half, so that's great. I'm Scott Rayner. For those who don't know me, I'm the lead security solutions architect for Intel. Been working in the CC industry since before SGX was out. Part of one of the original architects, developers, validators, you name it. I lead the enabling for our CC technologies. So from a technical perspective, so I work with all types of CC customers. Thanks.
Great. Well, really happy to have you on, Scott. I've had the pleasure of working with Scott for several years, and nobody's got his fingers deeper into the technology than Scott. Anybody else who'd like to introduce themselves this morning? Okay, if you later would like to, feel free to do that at any point and jump in to contribute as we move along. And I see Yash has joined as well. Thanks for joining, Yash. Okay, last time the meeting was capably organized and delivered by Yash, and we had the great update from Paul on his topic, as well as the related work on the update from the Verizon project. That's a good recording if you happen to miss the meeting. And I think that was also where we talked about for maybe the first time. I think we actually discussed it maybe lightly in previous meetings, but we have this new research fund that we'll talk about in a little bit. I didn't catch any announcements from anybody. Pause here for a moment if there were CCC related announcements. But I think we probably have no news this week along that front. And that brings us right to our first topic, and this should be a pretty quick one. So if you weren't here last week, the idea is that we want to help fund academia to do research into confidential computing and help move the ecosystem forward from like the academic aspect outward. And to make sure that we've got a diversity of viewpoints approving those funding proposals, we need a couple of volunteers. I think our target is to have at least 3 companies, but we could have N different companies. But mostly we need some volunteers here to help round out the viewpoint from the generous donations from TikTok and potentially other companies in the near future.
I think we have several volunteers that last committee meeting. I think, let me bring this up. Is someone else interested in this? Oh, I cannot share it. Okay, so the document, Confidential Computing Consortium Research Fund document. In the last section, we have Reese, Vincent, Mona, Mike, Dan, Caroline, and the 6 chairs.
So when we say six chairs, had they put themselves forward, or did we suggest that?
I think we suggest that, not what a volunteer.
Okay, so I think it's good to keep the SIG chairs informed, but until they actually volunteer themselves, we probably want like named individuals here. Fritz? Fritz's system is preventing him from coming off of mute.
Does this work now? Okay. So I just wanted to pitch in. Last time I didn't think this with you then. I think last time there was a discussion on whether one company should be represented twice. So I'll leave it to you then to come up with a solution here, whether you want to join and then I won't, or whether. Okay. So just wanted to say like both is fine with me, but whatever we come up with.
Yeah, I think my name was offered on the list since I'm TAC chair, but I don't necessarily have the bandwidth for this particular activity anyway.
And I think it's entirely appropriate to deputize anyways. I don't think that's a problem.
Right. So I don't know, I think this is a great list. So if we already have these volunteers, we'll see what Mike adds to the list here. Fritz is already at the top of the list, Mike, but thanks. So that already looks like enough volunteers that we need to make this move forward. So I think we are good there, and other people can certainly join in. So you're happy with that list, Mingshen?
Yeah, we can have two more if anyone else want to join, but I think it's good enough to move forward.
Great.
Maybe
Great. I
just
think
to
so
say
too.
one more thing there. I think Mona was just in the discussion last year, but I don't think she committed to joining the PC. My argument was just that Intel had this great experience, so we should definitely rely on their experience in running these things. So maybe that's something like in Scott's direction. If Mona isn't like available for this, maybe Scott can find someone else from Intel that is close to all of the great things you've done in the past, because I know you have all of the experience running these. So we're definitely really welcome to have that kind of like convey here as well.
Yeah, I can work on that for sure.
Awesome.
Yeah.
Thank you.
Can I suggest we also make someone the owner? Someone's actually going to run this and make it happen. Otherwise, people will just be nice together. Will not actually move things forward. And I think it does need a lead.
Would that be Mingshen?
Yeah, I can help. Yeah, I can lead this.
Okay.
So I think once this form, the next step is we discuss offline, not occupying the tech time, because currently we only have 1 hour. And then I'm planning to present a formal plan, maybe next tech, and then just execute.
Okay.
Sounds good. Yeah.
Yeah, that sounds great. I think we have space in the next meeting for that. And we can double check that near the end of the session today. But that's great. That's definitely enough, in my opinion, to get that process moving forward. So I'm going to switch us forward in topics then to the budget, and we'll have about 15 minutes here to get some discussion going. The short version of this is, I think we may as well be flat going 25 to 26 on our normal expenses. And so that's, we allocate a little bit of travel budget for the projects, a little bit of budget for their test infrastructure, and then some allocation for mentorship so that we've got some funding to help bring people into the community who wouldn't otherwise be able to get involved in confidential computing. Typically, we underspend on these, but these are very small in proportion to other aspects of the CCC's budget. So right now, outreach takes most of the CCC budget. This year, it was mostly event-driven. I think that might change going into 2026. What I would like us to do are to identify things that we can meaningfully advance, somewhat without concern for what that cost is at this point in the discussion, just so we can figure out how we can meaningfully advance confidential computing. We will, after we finalize these discussions in the next meeting or two, take that to the board, and the board's going to say, all right, well, we either have enough money to do this or we don't, and then we can get into some sort of negotiation. But I'd like us to figure out what those things are right now. Yash got his hand up first, so go ahead, Yash.
So I'm looking at the mentorship actuals B0. Is that because the funding for the mentorship program comes from the Linux Foundation and not from the CCC? Because we did have like 4 mentorship programs that are all funded.
Yash, that is on my list to ask the others when they send out the next budget, because nothing appears on our budget. But I know those people, the approval for the payments came through, but I'm not sure where they pull that from. So
Yeah, it's
I'll check on that one.
I think I remember when we had the budget discussion last year, the reason that we had put the number a bit higher because we were expecting that we will have mentorship programs and the funding will come from us. So if it's not coming from us, then we don't need to even budget 18,000 for it next year. Like if it's coming from the Linux Foundation directly, then yeah, that's a place we don't need to budget for.
Yeah, it's on my list to check. I'm just waiting for the new budget to come through, and as soon as I receive that, I'm going to ask questions amongst other questions.
Okay, thanks for catching that, Yash. Mingshen?
For the travel budget, is this different from the outreach travel budget, or is it specific for the project?
I believe what we see here is for the projects. So we allocate a small amount of money per project so that they can go represent their project at a conference.
Okay.
So this is specifically for project maintainers.
But haven't been used in this year.
I'm a little surprised that it doesn't look like we've spent any on that. I know that I want to say that some of the projects have sent out requests for authorization, maybe Verizon, maybe not. Maybe that was last year.
Okay, sounds good.
Mike?
Hi. Yeah, so this is horribly circular. I'm aware of that, but the GB is trying to work out what the main priorities at the strategic level should be. And that may well maybe not override, but is also going to play into discussions about where to spend budget from this side. And that's kind of complex, really. So we've got a number of proposals. We expect them to be hopefully agreed, what we're going to do in a couple of weeks' time, a week and a half's time. But until then, it's kind of difficult to know where we go. So yeah.
Yeah, so a different way we could have structured this is I could have asked for priorities and we've gone through a prioritization exercise. We can still do that out of band from this meeting. That's still probably a good thing to do. What I think we want to figure out though are there a few somewhere between 1 to 3 big ticket items that if we put something on the order of $100,000 into them, we would get some meaningful impact for the community. Anything smaller than that is, we can probably get it in, it's not a big deal. So let's think of things that are meaningful. The two things that we have identified over the year are the technical community architect and a security audit for the SPDM project. The experience that we've had with technical community architects is that we had a large appetite for what that individual could do. We have difficulty attracting and retaining talent for the amount that we budgeted. So I'm inclined to either double that budget and make sure that we retain a talented individual and do something meaningful with that time, or we say, this is too difficult for us to manage, and it's difficult to go through the hiring and management process, and let's just scrap the idea of having a technical community architect. And given how much time we have today, let's maybe focus on that rather than the second item for the security audit.
Could we briefly go over the SPDM thing, because that's new to me and I'd love to know a little bit about it, please.
Okay, we'll try to hit that quick. It's a security audit. So this firm that's associated with the OpenSSF, as I recall, has what's the right word? They have put together a bid on what they would do for a security audit for SPDM, and we've got the details in some email thread from months ago that we could circulate. But a security audit to bring in a company to do something is on the order of tens of thousands, and that's not something that we budgeted during 2025.
So what is the thinking behind that? Why is it needed now? And also to Ming Shen's point, is there any money we might be able to get from Alpha Omega? Sorry, Fritz, and I'm jumping in.
No, I want to add context on the SPDM, because SPDM is a DMTF protocol, right? And there are currently, I think, two big implementations of that protocol. So there's libSPDM, which is a C-based library. It sits under the DMTF GitHub. And then the same people, mostly Jiwen Yao, some other folks, partially from NVIDIA, partially from other companies, opened up also the SPDM RS implementation, and this is currently sitting under us, under the CCC. And so partially same people, but different programming language. This is SPDM RS, the Rust implementation. And I think this story is coming from kind of CCC going to the SPDM RS folks saying, hey, we have money, don't you want to make a security audit? And then once we went to the company that makes this, they said, oh, that's a big protocol, that's going to be a lot of money. So I think that as far as I am aware, that's the story. This is not coming from like SPDM RS folks. This is coming from the CCC going to the SPDM, going to the company, and now it's 70K, and now, okay, do we want to fund this?
So when we said it's always nice to have some auditing going on, but not at the level of 70,000 that I'm aware of. And is this a protocol audit or is an implementation and architecture or architecture audit? Because there's very different things.
Yes. So
Implementation.
I also want to go into that direction. Yeah. So I'm not sure. So yeah, I didn't speak up in the email chain because we were still in early discussions there. But if we now talk about budget planning, I think at this point we can invest 70K better than doing like an auto of that implementation, or we can at least reduce it to like a specific subset of saying we want to look for a specific bug type or something like this, right? Because the protocol is a rather low level machine protocol, and so like it's like a full audit always sounds like, I don't know, end user and calling APIs or whatever, but this is arguably not what this is going to be end up used in, right? So maybe if we scope it better, or if we can figure out what we actually want to do, we can be smarter about this at 70K and throwing this at it.
Yeah, so we could definitely get together a small subset of people to tune the bid. But from an allocation perspective on this order of magnitude, we should decide if this is something that we want to support, recognizing this covers one project and we have more than one project. Is it something we want to do on an ongoing basis? Hey, we can help out one project each year, and that's better than helping out 0 projects each year. Or maybe we want to go ahead and ask the board that we want to do this for more than one project. What we don't want to do is, as a committee of 24 people, take a look at a bid and kind of spend hours going through that.
So I just asked a quick question. How close to graduation do we think SPDM is?
You mean SPDM RS, the implementation, or the protocol?
SPDM RS as a CCC project progressing in the maturity levels that we've defined.
As far as I understand, it is feature complete to, I don't know what version of the protocol, but there are always things being added, right? So it's in a good state, but yeah, it's a protocol.
When did we last have an update for them, Dan? It feels like this should take place as part of the update from them.
We could jump down to the schedule. It's a good question.
I saw some emails by Reno at some point, but I lost track of.
May of this year.
I don't know if we've updated this.
May.
We intended that they were to come in May. I don't recall off the top of my head if we actually got them in May. I don't know if somebody wants to go quickly reference the May 15th minutes to know if we actually got that update. So a similar question to what Mike is asking on, their level of maturity. Are they ready for an investment like this? Would be if the companies and individuals here are planning to use this SPDM implementation in products, then that's a pretty big vote in favor of, it would be really nice to know that this is at a high level of security. So I'm not going to ask for live responses on, is your company using this project? But that's a good assignment for the coming week, is to go take a look at the project, check in with the relevant departments at your companies, and figure out, is this the implementation of SPDM that you are going to be using as we start to roll out products that require SPDM?
And if so, whether your company might consider putting some of that 70K forwards, in fact.
Say that again, Dan. I'm not sure I understood. You're saying that you want to know, for those companies that are using SPDM, which ones are using SPDM in concert with these other projects that we have, for example?
No. What we're asking is, are there any companies who are using SPDM RS in product or planning to do so in the next few months, next year or so?
Got it.
Go ahead and grab the.
And I'll audition my answer here live so that other folks can correct me, because this, I think, ties into what we heard from Caroline, which is that since Microsoft uses a Paravisor to provide support for legacy OSs, that we don't use SPDM. We have our own VTPM code inside of the Paravisor, which is OpenVMM. So I don't see, I think SPDM, if I'm understanding correctly from previous discussions, is for those VMs that do not have a Paravisor for.
No, so maybe we have Stephen on the call. Maybe actually we can get Stephen or someone from the SPDM folks to actually give maybe even a tech talk about SPDM to us, one of the next sessions. So SPDM is actually one of the core attestation protocols that are currently deployed on all of the hardware devices. So when you want to talk to an entity to attest it, currently you probably do this via SPDM. So there's like competing things like EAT or ARM-CCA does it a little differently. But for example, if you talk to with NVIDIA, so like if you talk with an NVIDIA device right now and attest it, you are using the SPDM protocol, and whether like it's running deep down or what you're exposed to, doesn't matter. At some point across this way, you're using SPDM. And so this SPDM RS is probably being used on the side of the responder. So talking about data station responder. And then the requester is using its own version of the SPDM implementation. So it's like a protocol negotiation going on between the two endpoints that wants to attest and the entity that does the attestation, and then you get the evidence from the device. So like the Paravisor part is correct, but still below that you use SPDM to attest the core TVM, for example.
Right, and I see David's got his hand up. I'll just ask, just to confirm my understanding, Fritz. So we use our attestation interfaces inside of our Paravisor, and you're saying that within that Paravisor, they might be using SPDM when they choose to have an NVIDIA GPU, for example, as the attester, and we're the relying party.
Correct.
Got it. Thank you.
For anybody else that wants to ramp on SPDM, Sam Ortiz gave a talk on TDISP and SPDM back in 2023 that is all still accurate and relevant, and his slides are at this Outstation SIG meetings repository, and the recording is in the Outstation SIG playlist on YouTube, and you can just look for that date. We will need to switch over to make sure that we get Mingshen his time for the tech talk, so we can maybe handle one or two quick questions. I saw somebody had their hand up, maybe it was David, and dropped, so cool.
Yes, I had it. So, I mean, I was just going to say the same thing about SPDM, the responder library from the DMTF is certainly being used for devices to support the responder attestation. When devices come up in the data center and the PMC has attested, example, we are doing it for CXL, Compute Express Link. So therein, when we have to add the, and we use like TSP over there for confidential compute scenarios.
Okay.
So first we have to attest it, and the responder supports this library. Generally, it is the DMTF libSPDM or proprietary implementation. The requester
Okay,
also
great.
has it.
Thanks for that added background for people. And again, I think there's some links going around in chat for people that want to learn more. So definitely more than we could talk about for budget today, but let's come back to that. So I'll send more details on the audit proposal to the list. And then we'll also want to talk about this TCA role. This is mostly something that Yash and Rian and Renu have context on, because we've tried to manage this role in the past. But this is a gist of what we tried to cover with the technical community architect. So we'll come back to that next time. And let's go ahead and switch things over to Mingshen. I'm going to stop sharing.
Yeah, and thanks for controlling the time, monitor the time. So we still have 20 minutes. Donghang is my colleague from TikTok who present this project. I'll give an overview. Donghang, can you share the slides in the meantime? We open source this project. This project called Trustless Attestation Verification. We open source this project last year, end of last year and early this year, and mainly to address the trust boundary of attestation verification service. The method we're using is zero knowledge proof, or purely mathematical tool to do the attestation verification. And then once when we open source, a lot of people are interested in this project and also contribute, ask questions in the open source community. But open source, attestation is not simply like comparing the measurements and collateral. So we thought this good to contribute, donate as a CCC project, and integrate with Verison as a whole. So that's why this time we want to reintroduce this project in CCC and seek some feedbacks in probably this and the next two tech meeting, and then we decide whether to accept this project as a CCC project. Yeah, Donghang can share the slides.
Yeah, can you hear me well?
Yeah, please go ahead, Donghang.
Yeah, thanks everyone. Sorry, I have to restart Zoom so that I can have the permission to share my screen. So yeah, thanks Mingshen for the introduction. And our project is called Trustless Attestation Verification. And today I'm going to talk about the idea behind and what's our open source status right now and our future plan. So this project is currently open sourced in GitHub under TikTok Privacy Innovation. And yeah, we can start here. Let's first talk about the scenario of this project. Now we are considering a Redan party using a TEE in cloud service. So basically, you can think of this as the Google Cloud, and the Redan party wants just to use their TEE nodes. And the first question for the Redan party is of course that this cloud environment has basically very limited or even no visibility to the Redan party. Redan party does not know what's happening inside. And the first question is natively, do I really interact with a TEE node or not? What if this cloud service is malicious and just provide normal machine? Then the moment that I send the data to this cloud environment, the privacy of my data got immediately lost. And thankfully, we already have solution for this. The attestation can enable the TEEs to prove themselves. And since this is the Confidential Computing Consortium meeting, I will not just introduce this in detail. So the attestation procedure usually check several things. For example, it can check the certificate chain of the certificate. It will check whether the report is properly signed. It will also check some vital properties of the TEE nodes, such as the firmware version and microcode version. So if everything's good, the Redan party now can be confident that I'm actually interacting with a legit and security environment. And in the cloud setting, there are several ways to do attestation. The first one is obviously the TEE node can directly send the attestation evidence directly to the Redan party. So this is more like a peer-to-peer way. However, in the cloud setting, especially in reality, people prefer a kind of another architecture. So here, there will be a attestation verification service. And for the rest of this talk, we will call it AVS. So this service is usually hosted by the cloud service provider. So now instead of allowing TEE to directly send the attestation evidence to the Redan party, instead, now TEE can send evidence to the AVS. So AVS can verify the attestation report on behalf of the Redan party. And if everything, then simply just sends the attestation result back to the Redan party. So there are a lot of advantages. For example, now it's easier for the cloud service provider to manage reference values. Redan party does not need to track all those values. And also the remote service attestation service now can be easier to integrate with other cloud functionalities such as authentication and token issuing. And it's also good for the Redan party because Redan party does not need to know how to verify the attestation evidence. So its computation burden is also eased. However, this structure, although with all these advantages, it also brings problems because now the attestation verification service has to be trusted. So in ideal world, when we use the TEE nodes, so we want to only trust the TEE node itself. So that's the ideal world on the right-hand side. However, right now in practice, on the left-hand side, we now have to trust both the TEE and the AVS. And since the attestation verification service is usually hosted by the cloud service provider, so now it also means sometimes we must trust the cloud service provider as well. So although the cloud service provider are trustworthy most of the time, but there are still some corner cases that might happen. For example, what if the attestation verification service becomes malfunctioning or buggy after some version update? Or what if now the attacker wants to launch an attack on this system, since the security of the system depends on its weakest part? Although the TEE environment is secure enough, but now the attacker can just choose to attack the attestation verification system. So in general, it's like the larger trust boundary means larger risks. And so the next question is natively, can we make the AVS trust this? So what if the attestation verification service can prove to the Redan party that it is following the correct attestation logic, which means it is being honest? And this can actually be solved by cryptographic proof. So now we can say instead of trusting this service, you can actually just trust math. And the crypto tools we use here is called zero knowledge proof, and it's basically a two-party cryptographic protocol. It can allow one party to prove to the another party that the statement is true without revealing any additional information. For example, that you can prove that you are a citizen of a country without even giving your name or your passport, let's say. Or you can prove that your age is over 18 without disclosing your actual age or your ID card. So this concept actually is much more popular in the community of blockchain. And with years of development, the zero knowledge proof becomes very efficient to prove very large scale of computations. Specifically in blockchain, actually the zero knowledge proof is used to prove the correctness of the computation. For example, in Ethereum, people use it to verify the off-chain computations. And in our scenario, actually, it's very similar. What we want to prove is that the attestation verification service is actually running the attestation logic correctly. So it's also correctness of the computation. And there are several variants in the zero knowledge proof family that are very good in our use cases. For example, one of them is called zk-SNARK. It has several properties such as the proof verification could be very fast and the proof size is constant. So in our scenario, this means the computation burden and the communication burden for the relying party will be very small. So it's more kind of user-friendly. That's the good part we want. And our solution here is we want to embed zero knowledge proof into the attestation verification. So now the attestation verification service need to generate a zero knowledge proof so that anyone can verify that the attestation service actually is running the expected attestation logic. So next is the basic flow of this system. So we will have a setup phase. It can be either trusted or not trusted, depends on what kind of zero knowledge protocol you are using. But the general idea is here, you will have, first you will have attestation verification implementation. You can put it online and everyone can audit, endorse, or challenge it if they find something is wrong. So after this phase, we will have an agreement of a version of attestation verification implementation so that everyone think it is good. So this can be put online so that everyone can check. And next step is actually during the attestation verification, when TE sends the attestation evidence to the AVS, AVS will actually generate two outputs. The first one is the attestation result, and the second one is actually a zero knowledge proof. And this proof is used to prove that the code it runs is actually consistent with the open source version that we just built in the trust phase. And now relying party can actually get just check whether this zero knowledge proof is valid. If it is valid, it means the attestation verification service is being honest. So you no longer need to trust it. Now you can only just trust math. And there are also challenges introduced by distributed confidential computing. Let's say we have a TE cloud service that is hosted by a lot of TE nodes, a cluster of TE nodes, let's say maybe 1,000 TE nodes. So in this setting, multiple TE nodes need to collaborate to provide this service. But as a relying party, if he wants to use this service, he needs to ensure that the entire cluster are secure. So in this case, the relying party may have to verify 1,000 attestation evidences. But also the TE themselves, they require mutual attestation before sending private data to other TEs. So these are all the challenges brought by the distributed confidential computing. And our goal here is actually we want to minimize the efforts of both the relying party and the TE nodes. For example, even with the 1,000 TE nodes running to support the service, the ideal case is the relying party can still only verify just one proof. and then it can ensure that the entire cloud is attested properly. And this actually can be done by a concept called proof aggregation in zero-knowledge proof. So in this figure, you can think of every single proof at the bottom is a attestation proof for one single TEE node. And the proof aggregation for ZKP can allow you to aggregate proofs layer by layer to form this kind of a tree structure. So we will have a one proof at the top. And the idea is the final proof, the proof on the top is valid if and only if all single proofs at the bottom are valid. So this basically is like now you only need to verify the proof on the top, and you can be sure that all the attestations for each TEE is done correctly. So now the proof aggregation in distributed TEE system, it can be much easier, since in cloud service, we can always find a role of orchestrator. This could be load balancer or gateway. So there's always a role that you can put you can grab all the attestation proofs together and aggregate them. So now the orchestrator can just do the proof aggregation and send one single proof to the relay party. And this single proof shows the honesty of the entire cluster of TEs. Also, mutual attestation becomes easier because previously the TEs might have to attest each other. So this is more like a peer-to-peer network. But now each TE can just send their attestation evidence to the orchestrator. Orchestrator will do the proof aggregation and send the aggregated proofs back to the TE. So this is essentially we are changing a peer-to-peer network into a star network to reduce the communication cost. So this is basically the idea we have as of now. And after we tested, we find the performance of the zero-knowledge proof sometimes may not meet your requirement. For example, if the proof generation is kind of slow and takes several minutes, but you are targeting at starting up a TE environment in seconds, so there might be a performance gap. So we have an alternative setup here. So generally, you can use our project, the trustless attestation verification, as the root of trust. And we can use that to bootstrap one single TE. And this single TE, inside this single TE, we can run a general attestation verification service such as Verizon. And this attestation verification service can be responsible for all the attestations for the rest of TE. So in this way, you can see there is still, you still don't need to trust like any party in this whole chain, because the root of trust actually is built on the zero-knowledge proof. So this still, you don't need to trust anyone in this system. And as for the open source status, our plan is we want to implement this idea with various zero-knowledge proof backends because they have different trade-offs. And as of now, we chose two backends. The first one is called Circum. So it's kind of like a circuit-based ZKP backend. So you need to write your computation logic in terms of a circuit. And the good part here is it has very transparent trusted setup. So you can use that to build trust. For example, the Confidential Computing Consortium could be responsible for the trusted setup. Everyone who wants to participate can join this trusted setup to make sure the general trust is built. Also, it has very clear security model, but the bad part is that it is kind of slow. In our experiments, it may take like 10, 20, 30 minutes to generate a proof. And the second backend we choose is called RISC-0. It's kind of more of like a virtual machine-based zero-knowledge backend. So the good part is now you can implement your attestation logic in Rust. So it's easy to implement, and also it's easy to audit, since if you audit the circuit, it's going to be a headache, especially for the large scale circuit. And the good part for the RISC-0 is it's very fast. If you, in our benchmark, the best we can do is we can finish the proof generation in 10 seconds. And the bad part is it has slightly more complicated security model, but it's still good. It's still verified. And now we have already open sourced 2 repositories on GitHub. The first one is called Trustless Attestation Verification. This is kind of serve as our main entry. It does not have any implementation inside, just introduce our ideas. And the second repo is our implementation in Circum. So this is already open sourced. So in this Circum implementation, we use Gross 16 proof, which is the ZK Snark. As I mentioned, it has constant proof size and very fast verification. So it's more user-friendly. And we do it for the AMD SEV SMP attestation verification as of now. Also, we provide a user-friendly command line interface based on Makefile. So as of now, we already got support from the community. We connect with multiple ZKP companies. And also we already see independent community contributors. They opened 20+ issues and submit 6 pull requests. These are not big achievements, but I think it's a good start since we are still early on this. And also, meanwhile, we are also testing the deployment of this idea in our internal use cases as well. So as for the general timeline, we will open source the RISC-0 version in this month. And we have several things in agenda for the future plan. For example, we want to provide a example code for the integration demo that so that's basically the implementation of this idea, so that we want to use our project bootstrapped TE to do the general attestation. So this is the first plan. We also have the second plan is we want to do a demo for the proof aggregation. So it's basically this idea. So we want to try to use one single proof to attest the entire cluster of TEs. And finally, we want to support some more TEs, since right now we only have attestation logic implemented for AMD SEV SMP, and in the future we plan to support more. That's the general timeline. So this basically the future plan. The timeline might not be exact accurate like for each queue, but that's the thing we have in mind. Yeah, that's basically everything I have today. Now,
Thank you for that. Do we have time for a question from you? From Fritz, rather, for you?
So quick question on, maybe you said it at the beginning and I missed it, but can you say why you actually chose zero knowledge proof? So maybe if you go back to your architecture drawing you had in one of the earlier slides, it always depends on the properties that you want to have, right? But what does zero knowledge give you? What properties that you wouldn't get by, I don't know, normal TVM? Because aggregation you can always do with a normal TVM and things like that. So why in your system you want the properties of zero knowledge?
So that's a very good question. So here actually the property that we want is just a cryptographic proof. And here the zero knowledge proof, the zero knowledge property actually is not used, since by default, the whole attestation procedure should be transparent, which means you should not hide anything in the attestation logic. So in this sense, what we need here is a cryptographic proof. It can be with zero knowledge property or without zero knowledge property. But after we dig into this field, we after checking what are available, we find that the zero knowledge proof families are actually the most efficient, and mainly thanks to the contributions of blockchain communities. So even in terms of the efficiency, they are faster. So that's why we choose zero knowledge proofs. But you are right that the zero knowledge property is not required in this scenario.
But attestation also has cryptographic statement of the relying party, right? So why cryptographic proof? I don't get that part.
So for the cryptographic proof, is more of like a proof of computation. We want the attestation verification service to prove that it's running the correct version of the code.
But you don't want to use CC for that.
Right, because this is kind of the idea of this project. We want to bootstrap the trust for the CC. since this is a attestation, before the attestation, you have no party to trust. And here,
Okay.
yeah.
Fair enough. Yeah. So sorry, Alec, go ahead. Maybe you can squeeze in.
I think I just had the follow-up question for your question, maybe just taking it up a level, which is to say, this attestation aggregator that you're proposing, it's not part of the TCB. Am I right about that?
Right, it's not part of TCB. It's more
Okay.
kind of like a attestation verification service.
Right. It's not part of the TCB, and you don't have to run it in confidential computing because of the beauty of zero knowledge proofs. I get it now. Okay, cool. Thank you.
Yeah,
And I
exactly.
think that's the question Fritz asked as well, but he asked it at too low a layer for me to understand it.
Yeah, that's correct.
I'm sorry, I just
Okay.
add on the zero knowledge part. The zero knowledge part we are discussing internally for the attestation itself. Currently, all is transparent. But if you think about the software attestation, some of the property you want to hide, but you want to prove to the reliant party. I can, for example, the network topology in the cloud setup. You want to prove that it follow a certain pattern, but you don't want to reveal all the details of the network topology or software configuration. Then you can use zero knowledge proof without revealing the detail, but can prove some of the property inside the cloud.
Well, thank you for the presentation today. Obviously, a little bit more that a little too much to squeeze into one meeting today. But I'm glad that we got through this. I hope people take questions now to the TAC mail list or to the TAC Slack. I know Mingshen is on both. I don't know if Ludong Hang is on either of those, but I imagine Mingshen can facilitate.
Yes, of course. And I think we can have another Q&A session in the next TAC meeting and also discuss the donation thing.
Okay.
Thanks,
Well, with
Mingshen.
that,
Thanks, everyone.
thank you, everybody.
Excellent.
Thank you.